Welcome back to my YouTube channel. Today we'll be dealing with Fluidmechanics N5. We'll be dealing with this question 1. So please subscribe to my YouTube channel if you have not subscribed, and click the notification button so that you'll be notified whenever I post a new video. Stay tuned. So I've given question 1 says there 1.1.1, what is the purpose of the bearing lubrication process in a metal? Obvious, guys. The purpose is to reduce friction. Yeah, is to allow the object, not them two metals, not to slide in contact. Is to prevent friction heat to take place. Yeah, things like that. But as you can see, this typical works hand in hand. You see, that question is almost similar. Is very close related. If you can check that, they say give two advantage of the bearing lubrication process in a mechanism. So you see, still is to remove it, like they've repeated one thing. In the advantage of yours will be will be the function. The advantage to what does it does? It removes friction heat. Still, the same answer on the top. We'll put them also here on 1.2. So yeah, guys. Okay, but so you see, you can do that, guys. See what is going on. Removing heat, dissipate friction heat. All those are typical things that you're supposed to do. But okay, it's fine. Nevertheless, okay, let me just um show you here. It's question 1. Some can say 1.1, the purpose of the bearing lubrication is to prevent direct mental to mental, is what I've said to you. Contact between different rotating and sliding component. I've said this is what I've said. 1.2 again, can say eliminate rapid material expansion due to rising temperature, is fine. Also here someone can say increases the expected lifespan of the material. You just can see increases the expected lifespan. That is an advantage. That is 1.2. Remember the advantage there. The advantages of a bearing lubrication. You see increases the expected lifespan of the material. That means your material might last longer than expected. Then the reduction of friction and wear. Yes, a reduced friction and wear. Dissipating here, they say dissipation of friction heat. I've told you this. Prevent decay due to corrosion. Any guys there, protect against harmful elements, power loss, friction. Any of these two, you will have your marks there. Good. Then 1.3 says define the absolute coefficient viscosity of a fluid relative to kinetic viscosity. Okay, these two, and to the value included units. Okay, unit. So viscosity, guys, just defined it, is the tendency to resist sliding layers of fluid measured in pars. You see, in poise. Measured in poise. The kinetic viscosity is the ratio of the absolute viscosity to the mass density. Here is the ratio. Is this ratio of what? Of absolute viscosity to the mass density. Here the mass density is this, is the density. That is mass density. So this is measured in meters squared per second. Meters squared per second. So this is what it is, guys. So let us get to the work now. Straight to the work. 1.4. dealing with calculation. They said a shaft. You take note, guys. If you are given a shaft, you must be very, very, very. It tends to confuse students. You know, students, they tend to make some mistake here. They tend to make some mistake and then they find that they're getting wrong. They confuse. Let me write here. Student, they confuse what? Piston and plunger and the shaft. These are not safety shaft. These are different things. But piston and a plunger, they are similar. So these two, you'll apply the same method. You'll use the direct formula. This goes under linear motion. Piston and the plunger will be under linear motion. But this one, guys, the shaft is rotating, guys. This gives you, you'll work under angular. Will bring you under angular motion. Angular motion. You must be very careful there. When you're dealing with shaft, think of the angular motion, guys. Angular. This will be of the what? Angular motion. Think of angular motion. Because shaft is rotating, guys. It's just simply, it does not go forward and backwards. It's simply rotating. It does not do, piston is going up. Like, check the piston, guys. If you have a piston like this, the piston, it has a linear motion, but we won't see it. If you see it, you can see it. Check, it's going down and then it's displacing, it's going back, but the piston is just rotating. Then the shaft is just rotating. It's just rotating, but the piston is moving upwards, backwards, from top dead center to the bottom dead center. Also, the plunger goes upwards and goes downwards, but the shaft is rotating. It's simply rotating. So you must take note. The rotation motion will bring us to under angular motion. So this, you must take note. Here we are under angular motion. Right, but we're applying our formula. We have to adjust. We'll make some adjustment there, guys. So bear with me as we attack this question. The shaft with a diameter 150. Shaft with a diameter of 150 rotates inside the bearing. You see, that is the shaft, the diameter of the shaft. It rotate inside the bearing with the diameter of this. This is the diameter of what? Of the bearing. So, and with the length, the bearing has the length of 170 long. That is the length. A rotary frequency. You cannot have rotary frequency if you're not dealing with angular. Check. This is the will give you it's under angle. As you can see there, they will rest per minute. Then content says the oil lubricating bearing has absolute coefficient viscosity of 0.02 parts with a density of 830 kg per cubic. So here it says 1.1.4 determine what? Calculate the power loss due to viscous force in kilowatts. So okay, let's check how can I check this, guys. Let us check. I want us to check, guys, how can I take this? Right. Power will be force multiplied by angular velocity, not linear. Remember, this is the shaft. Shaft is rotating. You see, this is what it will be torque, whereby we know that torque is equal to force multiplied by radius, whereby that radius is the same as diameter divided by 2. But this is the diameter of what? Of the shaft. So here we'll have angular, but angular again is given by 2 pi n. This is our angular. So let us try and compile this thing and see what will, let's maneuver our way through this. Let us maneuver our way. So we have given data there. Okay. We have data there. We've given diameter of the shaft. I will write it D, then I'll say S. Shaft D 150 is the same as 0.15. If you divide that by 1000 to pin meter, and the one of the bearing, I'll say D, then I write B here. So of the bearing is the same as 0.1503. Then the length there same as 0.17. It's in meters, in it. Then the rotating, we've given frequency there 0.0, and rest per mean. Our coefficient of viscosity is 0.02. Then the density is 830. Right, we've given it. So okay, we want to calculate with this information. So let me write here on the clean sheet. This is what we have, guys. This will be our data there. Right, this will be our data. So 1.4.1 the power, whereby you say the power is torque multiplied by angular acceleration, whereby but the torque itself is equals to force multiplied by diameter divided by 2, whereby obviously is radius, whereby again force, whereby again the force itself is equals to coefficient of dynamic multiplied by area multiplied by the velocity divided by thickness. So you check here, you see how cookie crumbles, whereby the angular velocity whereby the angular velocity what is this whereby the angular velocity is equals to 2 pi n. So you see, what do we have there? The steps, the necessary steps just to calculate this power we have to pass through. So yeah, let me start by this one. Let me find the angular, would be 2 pi. Then we insert that is 120. Then punch the calculator there we have, but now is what it's in rest per minute. Okay, then we're supposed to divide this by 60. Oh, be careful, isn't it? Divide this by 60, because you can see there will be 2 pi, that is 1, divide that by 60, then this will be what? 2 pi into 1, that divided by 60. We'll have 125,664. This simply, it's an angular, is measured in what? In rads per second, right? So we have this now. Okay, let's go forward for the for the force. Using force, we'll use this formula. Now let's attack using force. Coefficient of viscosity is 0.02, but now here the area, I don't know the area again. It's another thing. Here, I don't know the area. I'm supposed to calculate the area again. You must take these steps, guys. Area will be pi dl. Take note. Let me write, because this diameter must be very careful. Must be the diameter of the shaft. Right. Must be the diameter of the shaft, guys. Diameter of the shaft. Multiplied by the length of the bearing. Shaft, not bearing. Shaft. Diameter must be of the shaft. Multiplied by the length of the bearing, not of the shaft. What this guy is saying now. Yeah, guys. This we are talking about rotary motion here. Yeah. Understood me? This is what you say. Then here will be pi. Diameter of the shaft is 0.15 multiplied by the length, which was 0.17. So from here, our that diameter of the shaft is 0.17, the length 0.17, 0.15, like that. Then the area the area will be 80.111 times 10 to the power minus 3. This is meter squared. We had the area. Right. Good. We have this. We have the area. Whereby our area there is 80.111 times 10 to the power minus 6. Then what about the velocity? This is the velocity. This x bar is velocity, or you can even use v. It is no problem. But this is the velocity. This indicates the velocity, which would be pi diameter of the shaft also multiplied by n divided by 60. Pi diameter of the shaft is 0.15, n is 1000, 2 divided by 60. Right. Pi into 0.15 into 121,200 divided by 60. This will be 9.425 meters per second. So we have this guy, which is 9.425. Divide this by this t. That t is the same as clearance, whereby we know that is d minus d over 2, the same as clearance. Then d is the diameter of the bearing. This must be of the shaft. We'll only use the diameter of the bearing when we're calculating clearance only. We'll use it there only, guys. There is no way that we'll use it. Only here when you're calculating our thickness, whereby we know this is clearing is the same. That T thickness is the same as the clearing. Our diameter of that is 0, what here it is 0.1503 minus 0.15 divided by 2. What is the clearing would be 150 times 10 to the power of minus 6 must be made. We have the clearance. So we can divide by that clearance. 150 times 10 to the power of minus 6. So if we punch this, we'll typically have the force. This is the necessary steps we're supposed to take. If we punch there, we'll get the force. Then the force will simply equals to what? Yeah. Punch this. Force will be 100,673 Newton. We have the force now. Remember, the aim is to have this force now. We can calculate the torque. Diameter we have, this is the diameter of the shaft. So we can calculate the torque. Then we are good to go. Then the torque is force multiplied by the radius, which will be diameter of the shaft. Remember, when the radius, if the radius is same as divided by 2, then what is that force? The force is here 1000,673 multiplied by the diameter of the shaft, which is 0.15. Divide this by 2, then we'll obtain the Mr. Torque here. Mr. Torque, Mr. Top Nose, 673 times that 0.1512. 12,508 Newton meter. It's measured in Newton meter. But this is the long way, guys. We are not done. The aim was to calculate the power. But we know our power is torque multiplied by the angular velocity. Now we have the torque. How cool is this? 12.508. The angular, we did calculate where it was. Here it's our angular. Let me crack it here. Multiply with this. You can see power. Punch this, guys. 12,508 times 125,664. How cool is this? Will be 157, like this, 1571,8 or what, 5. This is in watts. Then if you want this in kilowatts, simply divide this by 1000. Divide this guy by 1000. If we divide this by 1000, will be 1.572 kilowatts. I don't know which method we have applied, but this is the correct method. I don't know about your memo, but I think it's very wrong, your memo. On this paper, this is what I know. This is a shaft, guys. Just bear with me. Do not worry, I will give you some real contact. Just subscribe there. So we'll go together drilling these questions, guys. So this is what we have. These are the necessary steps supposed to take. Remember, that was typically 8 marks. You see, 8 marks. You see, I did not rush so that you could understand. So it's 8 marks. So 1.4.2 kinematic viscosity of the oil. Remember, if here is the density of the oil, you've given us the density of the oil. That means we'll use also this. We know that Kinetic viscosity, guys, is equals to coefficient of dynamic divided by density. This will be density of the oil that we'll have. Then this will be equals to, we know that is 0.02, divide this by 830. So what will be this value? What will obtain there? This is simply 24,096 meter squared per second. So this is what you will have, guys, for this thing here. Will be our right. Oh, sorry about this, sorry about that, guys, sorry about that noise. So 1.4.3, the power lost due to viscous forces. You see, if the shaft is not rotating but move axially through the bearing with the velocity. Oh, I don't know that. I wonder, do you understand that English there? Move Asian. Don't know, guys, that you've understood this English or what. Let me drink some sip of water here a little bit. Thank you, guys. Do you understand what is going on there? Now you're supposed to know that the shaft, I've told you that the shaft is rotating. Now they say it's no longer rotating according to this, but now it's moving axially through the bearing with this velocity. Remember, check this. Check your SI units. Your SI units is in meters per second. Now, they say now, take it as a linear. Now, we are telling you, they are violating the law, but you're supposed to use the way they want to see that you are claiming or you understand. Now, they say, now is moving axially. Like is moving like in a linear form. So calculate the power loss, the other power. Now talking about the power loss, this we want the power loss if we have this velocity now. So nevertheless, they've given us in kilowatt with 5 meters per second, but we want this in kilowatts. We have given our velocity there. It is now we know that the power will be like this. Now if we are dealing with linear, will be force multiplied by what? By the velocity only. Is no longer linear. Suppose just to calculate this, and we have this now. Then everything is done. Let's check there. If we know that the power now will be what is force. Vapor, we know that the force is what? Its area multiplied by, or you can say one and the same thing, whereby this is coefficient of dynamic or of viscosity multiplied by area multiplied by the velocity multiplied by the thickness. Right. Remember, this is simply force. Multiply also by what? By velocity. So, guys, this is this, guys, we're supposed to do, guys. Ladies and gents. Now it's no longer, we don't need our talk and what. No. They say this, let us take it as linear. 1.1.3. Oh, while I'm taking this, it's 1.4 point. So, guys, remember, power is force multiplied by velocity. Remember, force is given by this under this topic. Then the velocity is this, is given by x bar. under this topic, or you can write it as like this. So now coefficient of viscosity is 0.02. The area will not change, still have the same area, which is 8. They did not say the shaft will change the size. No, the area is still the same, but the velocity is changed now. They say it is what? It's 5. It's 5. Remember, the thickness does not change. Did not change the thickness or clearance, still remain constant for now. Right, multiply this into what? Our velocity is 5 again. You see what's changed? The value that changed there is simply the value of what? Of the velocity compared to the one of the angle. Right, now if you punch all of this, what will be the power there? Let's check our power here. So they said you guys supposed to find our power times 80,11 times 10 to the power of minus 3 times 5 all over 150 times 10 to the power of minus 6 times that 5. He said this in what? In kilowatts, isn't it? Yeah, I've obtained 267,037. This is in watts, but in kilowatts divide by 1000, isn't it? We'll have this power to be 0.267 kilowatts. This is what we have. This is what we have. This is what we have. You see? Now this is what we have. They did not say calculate the change in power. Yeah. Now this is what we have. Let's check the value of the first one, power. You see? This is what we have now. So yeah. So yeah, this is what you'll have, guys. Definitely this is what you'll have. Let me check something. 572 minus, just checking, 0.267. Yeah, no problem. So this is what we have, guys, so far. Do we still have another question? No. So this is how you will collect your all 20 marks. 20 marks in the back. You see, you entering the exam room already. You have a 20 marks. How cool is this? Then you go to compressibility. You take all your 20 marks. You'll be fine. You have food. Then you go. You see, like, guys, you can kill this paper terribly. So okay, guys, thank you for watching. Please do not forget to subscribe. If you have not subscribed to my YouTube channel, feel free to like, to comment, and then you can share this to your fellow classmates. All the best.